Part 4. Up until now, we've worked on explaining quantum mechanics and relativity and why those two things refuse to fit together. But now we're standing at the place where those two worlds collide, the black hole. And most people think that a black hole is just a giant vacuum cleaner in space, but it's not. A black hole is actually one of the most extreme laboratories in the universe. It's where gravity becomes so intense that our current theories begin to conflict with each other. And here's why that's a problem. Quantum mechanics tells us that information is fundamentally conserved. And in other words, at the deepest level of reality, information should not simply disappear. But according to the original work on black hole evaporation, black holes slowly lose mass by emitting what's known as Hawking radiation. If a black hole eventually evaporates completely, then the obvious question becomes, what happened to all of the information about everything that fell into it? And if that information is truly gone forever, then one of the foundational principles of quantum mechanics would be broken. But if the information survives somehow, where is it? How is it stored? And also, how could it possibly escape something that not even light can escape? Now, this is what's known as the black hole information paradox, and it's one of the biggest unsolved problems in theoretical physics. One of the most fascinating ideas to come out of this puzzle is called the holographic principle. That suggests that the information describing everything inside a region of space might actually be encoded on its boundary, almost like a three-dimensional image emerging from a two-dimensional surface. So if that idea is correct, then the information might be more fundamental than the space that it occupies. And if you think about what that means for a moment, like for centuries, we've assumed that matter was the foundation of reality. Now, some of the deepest ideas in theoretical physics suggests that information itself might be even more fundamental than matter, energy, space, or perhaps even time. And if reality is built from information at its deepest level, then we've reached a completely new kind of question. Could everything we experience, including consciousness, also be understood as patterns of information? Physics doesn't answer that question today, but it's exactly the kind of question that pushes science into its next revolution, and that is where we are going next.